If you have ever read like an ancient myth or maybe a foundational religious text and you caught yourself thinking, there's just no way the geography or the timeline here makes any actual sense.
Right,
I
yes.
mean, I think we've all been there, you know? You're reading about these ancient heroes marching due north to this towering mountain of the gods, but when you look at a modern map, going north just, well, it dumps you into the freezing, flat Arctic Ocean.
Exactly. It just doesn't line up.
Or you read about an ancient calendar that had exactly 360 days in a year. No leap years, no like messy fractions. And the modern assumption is always, well, they didn't have good maps, or maybe they just weren't very good at math.
Which is a very arrogant way to look at history, honestly.
Yeah. But what if the problem isn't the text? What if the map of the ancient world looks wrong to us today because the planet itself has literally physically changed shape?
It requires a massive shift in how we perceive our own reality. I mean, as humans, we naturally assume that the earth beneath our feet is a fixed, immovable baseline.
Right. Solid ground.
Exactly. We look at the equator, the locations of the North and South poles, the length of a solar year, and we treat them as absolute constants. But when we start looking at the synthesis of ancient human records alongside some very specific geophysical and astronomical data, well, that comfortable baseline begins to look incredibly fluid.
Fluid is definitely one word for it. Terrifying might be another. We are going deep today, really looking through a fascinating theoretical framework that's sitting in front of us for this deep dive.
And it is highly detailed.
Oh, yeah. The material we're analyzing is synthesizing astrophysics, geology, the epic of the Mahabharata, and even biblical texts detailing the lives of figures like Enoch and Noah. And the model it proposes is known as the cosmic contraction.
Right.
According to the synthesis, over a 16,000-year period, the Earth didn't just experience climate change, it actually shrank.
Shrank. Literally got smaller.
And in doing so, it altered our orbit around the sun, threw ancient calendars into total chaos, and physically dragged the locations of the North and South poles across the crest of the planet.
Now, for anyone listening, it is really important to establish the parameters of our discussion today.
Yeah, definitely.
Our approach here is purely analytical. We are treating these provided sources as a fascinating theoretical model to be explored impartially. We are not here to, validate or endorse any specific religious, historical, or political viewpoints that people might associate with these texts.
Right, we're just looking at the framework.
Exactly. Our goal is to examine the internal logic of this synthesis. We want to look at the math, the proposed geological mechanics, and the astonishing ways this theory attempts to connect tectonic physics with ancient human memory. It's an exercise in seeing how incredibly disparate data points might construct a single, unified geological event.
Okay, let's unpack this, because the sheer scale of what these sources are proposing is staggering. We are talking about the entire planet moving in ways that completely defy our everyday understanding of geology.
It's massive.
So let's start with the core engine of this whole theory, the initial catalyst. The texts argue that all of this crustal movement was triggered by a change in Earth's orbit. Walk me through the basic astrophysical mechanism here. What was happening to the Earth in space to kick this all off?
So the theory posits that the Earth's original orbit was significantly wider than it is today.
Okay.
Specifically, it suggests the Earth was situated at a solar distance of 1 NOAA astronomical units, or AU. And over a 16,000-year period, it decayed down to 1.00 AU.
And 1.00 AU is our current distance from the sun. That's the baseline we use today, roughly 93 million miles.
Right, exactly.
So we're saying the Earth used to be 10% further out in the solar system. But why would a planet just spontaneously drop 10% closer to its star? I mean, planets don't just change lanes without a reason.
They don't. And the sources don't rely on magic here. They point to external cosmic forces introducing drag into our orbital mechanics.
Drag, like air resistance, but in space.
Sort of, yeah. While modern mainstream astrophysics envisions a fairly stable, empty solar system, this model leans on the idea of the solar system passing through a dense interstellar medium, or perhaps experiencing a gravitational perturbation from a passing, massive celestial body.
Oh, wow.
Right. So if the Earth encounters a region of space with higher particle density like a cosmic dust cloud, essentially, or if the sun's own magnetic and gravitational output fluctuated, it creates infinitesimal amounts of drag on the planet.
Okay, I tracked that.
And over millennia, this drag saps the Earth's orbital momentum. And in orbital mechanics, when you lose momentum, your orbit decays. You are slowly, inexorably pulled closer to the gravitational center, which is the sun.
Okay, wait. If we're getting dragged inward, that means the gravitational pull from the sun is getting stronger on us. And it's not just a smooth, gentle ride, right? The text describes this as a violently disruptive process.
Very disruptive. And that brings us to the mechanical heart of the theory, the bevel gear system of the Earth.
The bevel gear system.
Yeah. To understand this, you have to remember that the Earth is not a solid billiard ball. It is a series of nested spheres. You have a solid inner core, a liquid outer core, a highly viscous mantle, and a thin, rigid crust on the outside.
Right.
In a stable orbit, all these layers have reached a sort of rotational equilibrium. They spin together in relative harmony.
Right, like a well-oiled machine.
But when you introduce this sudden cosmic gravitational shift moving closer to the sun, that harmony is completely shattered. The gravitational lock between the sun and the Earth's dense inner core begins to shift.
Because it's dealing with new forces.
Exactly. The internal mechanics of the planet experience massive friction and resistance. The inner core's rotation starts to slow down and shift its axis slightly to adjust to the new orbital pathway.
But the crust, the outside layer where we all live, has its own momentum. It wants to keep spinning exactly the way it always has.
You're hitting on the exact problem. The core is trying to adjust to the new gravity, while the crust is trying to maintain its original inertia. This creates immense friction in the mantle.
I can't even imagine the heat and pressure.
It's unfathomable. And this buildup of stress eventually overcomes the friction, resulting in what the sources call a whiplash effect. It's a violent acceleration or deceleration of the crust relative to the core.
That is a terrifying visual. I mean, it's like being on a massive bus going 70 miles an hour and the driver slams on the brakes.
Okay.
The chassis of the bus stops, but the passengers, the crust in this case, are violently thrown forward because they still have momentum.
That's a perfect analogy, yeah.
So if you're standing on the surface during one of these whiplash events, you aren't just feeling an earthquake. The entire gravitational and rotational balance of the planet is being violently yanked beneath your feet.
And the crust couldn't just slide smoothly over the mantle to adjust to this new reality either. The continents don't all have the same density, thickness, or mass.
Right, some are thicker than others.
A massive, thick continental plate like Eurasia is going to drag and resist movement much more than, say, the thinner oceanic crust of the Pacific.
So they act like speed bumps.
Essentially, yes. As the entire crust tried to shift to realign with the new rotational axis of the core, these varying densities prevented a clean, straight-line movement. The North Pole couldn't just draw a straight line from its ancient location to the modern Arctic. It was forced to take a swinging, wobbling, nonlinear path.
Which makes total sense if you think about it like a spinning top. If you have a top spinning perfectly on a table and you violently nudge it, you give it that whiplash, it doesn't just slide sideways and keep spinning perfectly straight.
No, it wobbles.
Right. It staggers, it loops, it does this wild, wobbling, drunken dance before it either falls over or stabilizes in a new spot. So the North Pole is doing this stagger across the top of the globe. Why does that specific wobbling path matter to us?
Well, the sources connect this astrophysical wobble directly to known geology. The text explicitly calculates that this pendulum swing pushed the North Pole heavily toward Europe and North America during its journey.
Toward Europe and North America.
Yes. And this wobbling path provides a shockingly elegant explanation for a massive geological mystery. It explains why miles-thick ice sheets formed over those Pacific Western regions during what we call the last glacial maximum, or the LGM.
Wow. Let's pause on that, because traditional science usually says, oh, the whole globe just got really cold. It was an ice age, and ice built up in Europe and Canada because they were far north.
Right.
But this theory is saying, no, those places were literally dragged into the active polar zone for a few thousand years as the pole staggered past them.
Exactly. The geological evidence of the LGM shows ice sheets up to 2 miles thick, covering places like modern-day Chicago, New York, and northern Europe.
2 miles thick over Chicago.
Yes. The sheer mass of that ice literally depressed the bedrock of the continent. But places in Siberia, which are currently in the Arctic Circle, were largely ice-free during this same period.
Wait, really? I always pictured the whole top of the globe just covered in ice.
No, Siberia was relatively clear. And the traditional model struggles to explain that discrepancy perfectly. But the cosmic contraction model argues that the crust itself shifted. North America and Europe were subjected to polar temperatures because they were physically relocated into the crosshairs of the wandering pole.
You, the listener, just imagine the scale of that disaster. You aren't just dealing with a lateral earthquake or like a bad winter. The ground beneath you is being physically dragged into a deep freeze zone. The entire latitude grid of the Earth is staggering under this immense cosmic pressure.
It paints a picture of a planet that is deeply, deeply unstable.
Which naturally begs the question, if the pole was wandering over North America and Europe, where did it start? If we rewind the tape all the way back before this 16,000-year stagger began, where was the top of the world?
The sources provide a very specific location. They claim that before the contraction began, the ancient North Pole was located at the Pamir Knot.
The Pamir Plateau. In Central Asia. We're talking roughly 39 degrees north, 72 degrees east. That is north of India, bordering Tajikistan, China, and Afghanistan. That is a massive, towering, mountainous region. It's often called the roof of the world.
That's the
But it is certainly not an icy ocean.
The altitude is actually a key component later on, but yes, it's a high-altitude plateau, not an ocean. The text uses a very specific, undeniable astronomical marker from the Mahabharata to back this location up.
Okay, let's hear it.
In the ancient Indian epic, there is a star called Abhit. Today, modern astronomers know this star as Vega.
Vega, okay.
The ancient texts state unequivocally that in ancient times, Abhijit was the North Pole star. It was the stationary point in the heavens around which the entire night sky rotated.
But Polaris is our North Star today. If you look straight up at the North Pole now, you see Polaris.
And the math linking those two stars is where this theory really shines.
Yeah.
According to modern astronomy, the angular difference in the sky between Vega and our current pole star, Polaris, is approximately 51 degrees. Yeah. And in the Mahabharata, there is a very famous, somewhat cryptic passage that records that the star Abhijit fell from the sky.
Okay, wait, let me visualize this. Let's say I'm an ancient astronomer standing in India. The North Pole is at Pamir. When I look straight up toward the north, Vega is my North Star. It's high in the sky, anchoring the heavens.
Right.
But then the Earth's orbit decays. The whiplash hits. The crust shifts by 51 degrees as the pole wanders away toward the modern Arctic. From my perspective, standing on the ground, Vega isn't straight up anymore.
Exactly.
Over generations, it literally looks like it fell from its high point in the sky down toward the horizon.
The 51-degree shift is the exact mathematical bridge between the ancient astronomical observation and the geological movement of the pole. The ancient writers weren't using metaphors here.
They were just writing down what they saw.
They were recording a literal optical reality caused by a shifting crust. And if you accept this premise that the pole was originally at Pamir, the entire geographical landscape described in the Mahabharata suddenly snaps into hyper-accurate focus.
Okay, I have to play devil's advocate here because this is where my brain starts to break a little bit.
Over.
I can see how moving the crust 51 degrees makes the star fall from the perspective of an observer. But if the whole Earth's crust tilted 51 degrees, wouldn't all the cities, rivers, and mountains in India have moved relative to each other? Like, wouldn't the East Coast suddenly become the North Coast? Wouldn't the map just be completely scrambled?
That is a very common misconception when trying to visualize crustal displacement, and the source material addresses it directly. You have to remember that the entire tectonic plate, the whole Indian subcontinent, along with the rest of the Eurasian mass, moved together as one cohesive, solid unit during this shift.
Ah, okay. Let me think of a good analogy. It's not like the cities are sliding around like loose change on a dashboard. The dashboard itself is tilting.
Perfect analogy. The internal geography of the plate remains completely intact. The distance between the Ganges River and the ancient city of Dwarka doesn't change. What changes is the orientation of the entire landmass relative to the rotational axis of the Earth.
Okay, I'm with you.
What changes is where the compass needle points. In the ancient world, if you held a compass, true north wasn't pointing to the modern Arctic Ocean, it was pointing to the Pamir Plateau. The ancients referred to this polar center as Mount Meru.
So when the ancient texts say the heroes, the Pandavas, traveled north for their final journey, we've been reading it wrong all this time because we've been using the wrong compass.
Precisely. The text details the Mahaprasthanika Parva, which is the great journey of the Pandavas to heaven at the end of their lives. The epic says they traveled true north.
Okay.
Now, if you start in central India today and walk true north using a modern compass, you cross the Himalayas, traverse the massive expanse of Tibet, cross into Siberia, and eventually end up staring at the freezing Arctic Ocean.
Right.
There's no towering mountain of the gods there. It makes the text look like pure fantasy.
But if true north was Pamir, the route is completely different.
Flawless, in fact. If you orient your ancient map so that north points to the Pamir knot, the itinerary becomes a literal set of directions. You travel north from India, you cross the Himalayas. Then, the text says they encountered a massive sand ocean known as the Voluka Arnav.
A sand ocean?
Yes. On a realigned map, right after the Himalayas, you enter the Tarim Basin and the Taklamakan Desert.
And the Taklamakan is legendary. I mean, its name translates in some local dialects to, you can go in, but you will never come out. It is a massive, unforgiving sea of shifting sand dunes. It perfectly matches the sand ocean.
And once you cross that sand ocean, you arrive directly at the towering, impossible mountain ranges of the Pamir Knot, Mount Meru, the center of the ancient world.
That is wild. The sources are basically arguing that these ancient writers weren't composing poetic fairy tales about mythical mountains in the sky. They were writing a literal geographical itinerary, a travelogue, based on a compass grid that simply doesn't exist anymore.
It completely reframes how we must view ancient mythology. And the sources take it even further. They point out that Uttarakuru, which is described in the texts as the mythical realm of the gods, a place of advanced civilization and perfect climate, perfectly maps to the Tarim Basin and the Tian Shan valleys.
Wait, really? But those places are brutal today.
Today, yes, those areas are harsh, but geological evidence suggests they were once lush, temperate, and capable of supporting advanced ancient cultures. By simply shifting the pole 51 degrees back to Pamir, the myth becomes a 3D topographical reality.
Okay, so if the top of the world was at Pamir in Central Asia, that completely breaks the rest of the map. If you move the top of a spinning ball, the middle of the ball has to move too. The equator couldn't possibly be where it is today. Did these ancient texts record where the middle of the Earth was?
They absolutely did. And we can turn to another foundational text, the Surya Siddhanta. This is one of the most important ancient texts of Hindu astronomy. It states unequivocally, with mathematical precision, that Ravana's Lanka, the legendary massive island kingdom from the Ramayana and Mahabharata eras, was situated exactly on the equator, at 0 degrees latitude.
Okay, but modern Sri Lanka, the island we call Lanka today, is at roughly 7 degrees north latitude. It's close to the equator, but it's definitely not on it.
Which has led many modern historians to assume the ancients were just slightly off in their calculations. But the sources suggest the ancients were perfectly accurate.
How so?
In ancient Indian astronomy, the prime meridian, their version of Greenwich, England, was a line drawn straight north to south through the city of Ujjain in India. If you draw a line straight south from Ujjain and you follow it down to where the equator would have been under this ancient shifted grid, you don't hit modern Sri Lanka.
Where do you hit?
You hit the region of the Diego Garcia and the Chagos Archipelago, deep in the Indian Ocean.
Diego Garcia, that's a tiny atoll today. But wait, let me check the coordinates. Today, Diego Garcia sits at roughly 7 degrees south latitude.
Let the math sink in. Modern Sri Lanka is 7 degrees north. Diego Garcia is 7 degrees south. The ancient texts say the great kingdom of Lanka was at 0. The equator literally shifted 7 to 10 degrees.
So the equator line moved on the map. But it's not just a mathematical line shifting, right? The physical landmass itself moved. And more importantly, the sources argue that this landmass buckled.
The buckling is the crucial piece of evidence. The sources argue that this shift wasn't just the crust sliding around a static sphere. The Earth was physically shrinking in size.
Okay, break that down for me. How does the ancient equator moving prove that the entire planet shrank? I'm not seeing the connection between a latitude shift and a deflating planet.
It comes down to the unbreakable rules of sphere geometry. On a perfect sphere, the distance between the North Pole and the equator is always, without exception, exactly 90 degrees of distance. Always.
Right. A circle is 360 degrees. From the top of the ball to the middle of the ball is a quarter of the circle. 1/4 of 360 is 90. That's just fundamental geometry.
Now, apply that fundamental geometry to the map we just established using the ancient texts. The ancient North Pole was at Pamir. Pamir is currently located at 39 degrees north latitude.
Okay.
The ancient equator, Ravana's Lanka, was at Diego Garcia. Diego Garcia is currently located at 7 degrees south latitude.
Hang on, let me do the math. From Pamir at 39 degrees north down to the modern equator is 39 degrees of distance. Then we have to keep going south to get to Diego Garcia, which adds another 7 degrees, so 39 plus 7. That is a physical distance of only 46 degrees on today's map.
The math actually supports your intuition there. The physical distance between Pamir and Diego Garcia today is only 46 degrees. But we just established that the distance between a pole and its equator must be 90 degrees.
Oh my God.
There is a massive continent-sized chunk of distance mathematically missing from the surface of the Earth.
It's just gone.
The sources argue that this missing distance is the undeniable geometric proof that the Earth shrank. The crust violently buckled and compressed during the cosmic contraction, bringing the ancient pole and the ancient equator physically closer together.
That is just, it's really hard to wrap your head around because we are so used to hearing about sea levels rising and falling. We think of sunken continents as places that just got flooded. But this isn't a flood. This is the Earth's crust buckling inward like a deflating basketball.
It's a structural collapse.
It's dragging massive continent-sized land masses down into the mantle. The sources mention Kumari Kandam, right? This legendary sunken continent in the Indian Ocean, deeply tied to ancient Tamil literature. Traditional history says it's a myth, or maybe a localized flood. But this theory says it didn't just flood, it was dragged into the abyss by a catastrophic tectonic collapse.
It was a catastrophic geographical compression. The tension of a shrinking sphere forces the surface layer to fold, overlap, and collapse inward, which naturally leads us to look at the other side of the planet.
Okay.
If the North Pole was at Pamir and the Earth's crust was buckling inward, what was happening at the antipode? What was happening in the southern hemisphere?
Right. Every pole has to have an exact opposite. If the top of the world was in Central Asia, where was the South Pole while all this was happening?
Again, we rely strictly on the geometry. If the North Pole is at 39 degrees north, 72 degrees east, the Pamir knot, then the South Pole must be exactly opposite on the globe. That places the ancient South Pole at 39 degrees south, 108 degrees west.
I am mentally picturing a globe right now, trying to find 39 south, 108 west. Where is that?
It is smack in the middle of the South Pacific Ocean. It is thousands of kilometers west of the Chilean coast in South America and just south of Easter Island.
Wow. So the South Pole wasn't sitting over the landmass of Antarctica like it is today. It was basically in the heart of Polynesia.
The implications of that coordinate are massive. It means that from roughly 19,577 BCE to 11,200 BCE, that entire region of the South Pacific was not a tropical paradise. It was locked in a massive, brutal polar ice cap, just like Antarctica is today.
Okay, wait a minute. We're talking about tropical islands, Easter Island, New Zealand, the islands of the South Pacific. You're saying they were covered in miles of solid ice.
The sources provide compelling geological evidence for exactly this. Let's look closely at Zealandia.
Zealandia, yeah.
Today, geologists recognize Zealandia as Earth's 8th continent. It is a massive continental crust, but 94% of it is currently submerged under the ocean. The only parts poking out above the water are New Zealand and a few smaller islands, which are effectively the highest mountain peaks of this sunken continent.
Right.
During the ancient polar alignment, the sources argue that Zealandia was a massive, solid landmass above water, completely covered in glacial ice.
Is there actual physical proof of that? Because ice that thick doesn't just melt and leave no trace. Glaciers leave immense scars on the landscape.
The scars are everywhere, if you know what you're looking for. The sources point to massive glacial striations.
What are those exactly?
These are deep, parallel scratches carved into the solid bedrock by the immense weight and movement of ice sheets dragging rocks across the surface. These striations are found extensively across New Zealand's South Island. Furthermore, look at Milford Sound in New Zealand. It is a classic U-shaped valley.
Right, because normal rivers carve V-shaped valleys as the water cuts down into the rock. But a glacier is a slow-moving river of solid ice. It's so wide and heavy that it bulldozes the entire landscape, carving out a massive U-shape.
Exactly the mechanism.
Yeah, the Rapa Nui people have this deeply held ancient myth that they didn't originate on that tiny, isolated island. Their oral traditions say they came from a massive sunken continent they called Hiva. And across the wider Polynesian triangle, there's the pervasive legend of Hawaii, the great sunken ancestral homeland.
When you look at the 94% submerged continent of Zealandia through the lens of those myths, a terrifying question naturally arises. How does a continental landmass of that size just disappear beneath the ocean?
Yeah, I mean, I understand sea levels rising when ice caps melt, but an entire continent going under. Sea level rise alone isn't enough to drown mountains.
The sources explain this as a catastrophic dual disaster scenario. Remember the mechanics of the theory. The Earth is shrinking and the pole is shifting. As the ancient South Pole moved away from the Pacific Ocean and began its wobble toward modern Antarctica, that massive Pacific ice cap began to melt rapidly.
Which puts all that water into the ocean.
Right. This caused a global, drastic spike in sea levels. But simultaneously, because of the cosmic contraction, the immense crustal buckling we talked about with Lanka was happening in the Pacific as well.
Oh man, so it's not just the water coming up, it's the ground physically falling down?
It is the ultimate geological nightmare. The tectonic plates beneath Zealandia and the wider Pacific were forced downward by the immense compressive pressure of the shrinking Earth. The crust collapsed inward, while simultaneously billions of tons of melting polar ice poured into the oceans right above them.
Total
It
inundation.
was a complete, violent inundation. The continent of Hiva, or Zealandia, was forced into the ocean depths, leaving only its absolute highest mountain peaks, places like Easter Island in New Zealand, surviving above the waves.
That paints just an apocalyptic picture in my mind. Imagine standing on this massive ice-covered land. Over a few generations, the ice is melting rapidly around you, turning the valleys into roaring seas. And then the ground itself just gives way and sinks into the mantle.
It's a terrifying scenario.
But let's take a step back here. There's a whole massive shift. The North Pole moving from Pamir to the Arctic, the South Pole moving from the Pacific to Antarctica, the Earth shrinking. It didn't just happen on a random Tuesday. The sources map this out over a very specific 16,000-year timeline. Let's track this process. Let's start at the very beginning of the timeline they lay out.
The time frame is crucial to understanding the mechanics. This was not a single overnight cataclysm. The sources outline a 16,000-year period of gradual, agonizing pressure buildup, which was punctuated by violent, catastrophic spikes as the crust occasionally snapped to release tension.
Okay.
The timeline runs roughly from 20,000 BCE to 4,000 BCE.
Okay, so take me to 20,000 BCE. What is the state of the Earth?
This is the starting point of the cosmic contraction. The Earth is still in its wider orbit at 1.10 AU. At this time, according to the mathematical deductions of the texts, a solar year is exactly 360 days long.
360 days. Which makes so much sense when you think about it. That is why all of our ancient circles in geometry have 360 degrees, right?
Yeah.
The geometry of the ancient world mirrored the calendar of the ancient world.
The mathematical elegance of the ancient world was based on their literal reality. At this 20,000 BCE mark, the orbital decay begins. We see the initial shock wave. The ancient advanced city of Dwarka, which is famously described in the Mahabharata, sinks into the ocean due to sudden, massive climate changes and the first major tectonic shifts.
So it's already starting to get bad.
Right, this is the very beginning of the Earth's orbit starting to contract, sending the first major whiplash through the planetary crust.
So it's a slow, agonizing grind for thousands of years. The pressure is building up in the tectonic plates, the oceans are sloshing around as the spin changes, and the ice caps are starting to melt and reform in new locations. And then we hit the major midpoint.
The midpoint is perhaps the most heavily geologically supported part of the theory. We jump forward to the period between 11,200 BCE and 11,177 BCE. Modern geologists know this exact time frame as the Younger Dryas catastrophe.
The Younger Dryas?
Yes, it was a period of wild climate swings and massive extinctions. But the sources map this perfectly to their timeline as the 55% mark of the total orbital shift.
55%, meaning 55% of the 16,000 years have passed, and 55% of the 51-degree pole shift from Pamir to the Arctic has happened.
Correct. By 11,200 BCE, the pole had shifted approximately 28 degrees away from the Pamir knot. It is now actively waddling over Eastern Europe and Scandinavia, dragging the Ice Age with it.
Now, what's happening with humanity during all this?
Well, socially, the texts note massive shifts in human civilization. The ancient Pandava lineage, the heroes of the Indian epics, effectively ends around 12,202 BCE. Their world is destroyed. Meanwhile, in Africa, which was geographically situated closer to the equator and far safer from the shifting polar ice caps, the biblical lineage of Adam, specifically through his son Seth, is beginning to rise and flourish.
The history is fascinating, but what really blows my mind is the math on the calendar at this 55% mark.
If you run the mathematical calibration based on the 55% completion ratio of the contraction, the Earth has moved inward from 1 point down AOU to roughly 1.045 AU. Because it is closer to the Sun, the conservation of angular momentum dictates that its rotation has sped up.
It's spinning faster.
Exactly. A year is no longer 360 days. By 11,200 BCE, the Earth is spinning faster, and the year has stretched to exactly 362.88 days.
Okay, I really want you to stop and think about the human cost of that specific number, 362.88 days. Imagine you are an ancient farmer in Mesopotamia or the Indus Valley. Your entire survival, the survival of your children, depends on knowing exactly when to plant seeds and when to harvest.
That's life or death.
Literally. You're using an ancestral calendar of 360 days, passed down through generations of careful observation. But now, every single year, your calendar is off by almost 3 days. Within a single decade, your calendar is wrong by an entire month.
And it compounds.
Yes. Within one human generation, you are literally experiencing winter blizzards during what your calendar says is the middle of the summer harvest. It is total agricultural and climatic chaos. You can't feed your people.
It would have felt like the end of the world, because the fundamental rhythms of nature were broken. The seasons were completely detaching from the calendar. This climatic chaos aligns perfectly with what we see in the geological record of the Younger Dryas. We see massive temperature fluctuations globally. We see the rapid catastrophic melting of the Pacific ice cap as the South Pole moved,
Which causes more flooding.
This triggered a massive spike in global sea levels, known to geologists as meltwater pulse 1A, where the oceans rose up to 20 meters incredibly fast, drowning coastal civilizations worldwide.
The trauma of that event would be seared into human memory forever. But humanity didn't just sit around letting the sliding calendar starve them to death. Somebody had to figure out what was going on. Somebody had to fix the math.
And that somebody, according to the synthesis of these biblical and historical texts, was the prophet Enoch. The sources placed Enoch's lifetime right in the thick of this chaos, around 8,869 BCE.
Okay, let's check the math on the timeline for Enoch.
If we run the timeline from the start point of 20,000 BCE, Enoch's era puts us at roughly the 76% mark of the total 16,000-year contraction process. At this point, the Earth has decayed to 1.024 AU from the Sun. The North Pole has shifted about 39 degrees from Pamir, and the physical diameter of the planet has already shrunk by over 72 kilometers.
And Enoch is famously given a brand new calendar. If you read the book of Enoch, there is an entire astronomical section where he says the archangel Uriel comes down and gives him this highly specific, mathematically rigid calendar on exactly 364 days.
364, yes.
It is perfectly divided into 52 weeks, with exactly 4 seasons of 91 days each. It's an obsessive correction of the timekeeping.
From an analytical perspective, Enoch's 364-day calendar is the ultimate midpoint calibrator of this entire theoretical model. The existence of a 364-day calendar proves that this orbital and rotational shift wasn't a single random cataclysm that just bumped us magically from 360 days to 365. It was a measurable stepped progression. It proves the Earth's rotation was speeding up gradually as it shrank. It went from 360 days in the Golden Age to 364 days in Enoch's time, before eventually settling at our modern 365.25 days.
It's incredible. It's like finding a transitional fossil in biology, but for the evolution of the Earth's orbit. It bridges the gap perfectly.
It really does.
But if Enoch is at the 76% mark, that means we still have 24% of this immense cosmic pressure left to go. The Earth is still shrinking, the tension is still building, and that brings us to the climax in 4000 BCE.
The final snap. The sources correlate this geological climax with the Great Flood of Noah. After 16,000 years of gradual pressure, sliding poles, and intermediate spikes, the Earth's geological tension reaches an absolute critical threshold. The crust simply cannot buckle or bend any further without shattering.
So what pushes it over the edge?
The text suggests that a final cosmic trigger initiated the break. They point to an external gravitational or electromagnetic influence from the direction of the Pleiades star cluster, known in ancient texts as Kritika.
I need to understand the mechanism there. How does a star cluster, which is light years away, trigger a crustal collapse on Earth? Are we talking about a meteor shower or something more fundamental?
The theory implies a massive cyclical alignment. It posits that as the solar system travels through the Milky Way, it occasionally passes through regions of intense gravitational resonance or localized cosmic dust clouds associated with the Pleiades.
Okay, so it's interacting with our whole solar system.
Right. Because the Earth's crust was already under unimaginable breaking point tension from the 16,000-year contraction, it didn't take much to push it over the edge. A slight gravitational tug or a disruption in the sun's magnetic field caused by this cosmic alignment was the proverbial feather that broke the camel's back.
This brings to mind a rubber band analogy. Imagine you have this massive planetary-sized rubber band representing the Earth's crust, and it has been stretching, twisting, and pulling for 16,000 years as the core shrinks beneath it.
That's a lot of stored energy.
The stress stored in that rubber band is unimaginable. And when that final cosmic trigger happens in 4000 BCE, the rubber band finally snaps. It doesn't just vibrate, it completely shatters the Earth's crust. It releases the final 24% of the pent-up geological pressure all at once.
The geological violence of that final snap would be apocalyptic beyond human comprehension. The sources describe the crust literally rupturing along thousands of miles of fault lines. The biblical text of Noah famously mentions the fountains of the great deep breaking open before the rain even starts.
So it's coming from below.
Yes. This aligns perfectly with the sudden, catastrophic collapse of the crust.
And when the dust, the water, and the ash finally settle from this cataclysm, the North Pole and South Pole are completely locked into their modern frozen positions in the Arctic and Antarctic. The Earth's orbit stabilizes at our current 1.00 AU, and the length of the year finally settles in our modern messy fraction of 365.25 days.
The 16,000-year contraction is complete. The planet has found its new, stable equilibrium. The map is drawn.
Okay, we have talked a lot about the changing geography, the ancient texts, and the timeline. But I want to spend our final major section really digging into the raw mathematical physics of this shrinkage. Because it's one thing to say the Earth shrank, it's another to prove how it mechanically happened. The sources provide a mathematical proof for this, pulling heavily from a concept known as the hydroplate theory.
To understand the physics of the shrinkage and where the fountains of the great deep came from, we have to look at the hydroplate theory. This theory proposes that in the ancient pre-contraction Earth, there was a massive layer of subterranean water trapped roughly 10 miles beneath the granite crust.
10 miles down.
Right. It was essentially a global, underground ocean under immense pressure.
So when the final snap happened and the crust shattered, that highly pressurized water violently erupted into the atmosphere. That explains the 40 days of rain in the flood myths. It wasn't just weather, it was subterranean water being ejected into the stratosphere and falling back down.
Look at the physics of it. When that water was expelled, the crust had empty space beneath it, allowing it to collapse inward and shrink. And the math provided by the sources tracks this perfectly by looking at angular momentum and the moment of inertia.
The moment of inertia.
Yes. The sources state that during this entire 16,000-year process, the Earth's moment of inertia decreased by 1.46%.
Okay, wait, let me reason through moment of inertia. Inertia is an object's resistance to change. So the moment of inertia is basically how spread out the mass of a spinning object is from its center of rotation. If the mass is far out, it has high inertia and it spins slower. If the mass is pulled in tight to the center, it has a lower inertia and it spins faster.
You are describing the classic figure skater analogy perfectly.
Right. When a figure skater is spinning on the ice with their arms stretched wide, they spin at a relatively slow, controlled speed. But the second they pull their arms in tight to their chest, reducing their radius, they suddenly spin much, much faster in a blur.
The Earth did the exact same thing. We know the rotation sped up because the year went from 360 days to 365.25 days.
So it had to spin faster.
Exactly. The Earth was completing more rotations per orbit. Therefore, like the figure skater pulling her arms in, the Earth must have pulled its mass inward. It must have physically shrunk.
But unlike a figure skater, the Earth doesn't have arms to just casually tuck in. It is made of billions of tons of solid rock, granite, and tectonic plates.
And that is where the math translates into terrifying geological reality. Because the moment of inertia is mathematically proportional to the square of the radius, a 1.46% decrease in inertia dictates that the Earth's diameter must have shrunk by 0.74%.
0.74%, which honestly sounds like a tiny, insignificant percentage.
Until you calculate it in actual kilometers on a planetary scale. 0.74% of the Earth's diameter is roughly 95 kilometers.
The Earth lost 95 kilometers across its middle.
Yes. And if you lose 95 kilometers in your diameter, geometry dictates that you lose about 300 kilometers in your total circumference.
300 kilometers. I want you to really visualize this. Imagine driving 300 kilometers, say, from New York City to Boston or from London to Manchester. Now imagine taking a belt that is wrapped tight around the equator of the Earth and suddenly tightening it by that entire distance. Where does all that extra rock, all that continent go? It can't just vaporize.
It has nowhere to go but to crush into itself. This sheer, unimaginable geological violence forces tectonic plates to collide with unbelievable force. This is the mechanism that pushes up the massive, jagged mountain ranges we see today, like the Himalayas and the Andes.
They're huge.
Enormous. It also causes the immense crustal buckling that sinks massive land masses like Zealandia and Kumari Kondam. The Earth didn't just passively shrink, It violently crushed its own surface to fit a new, smaller mathematical reality. The mountains are the wrinkles of a shrunken planet.
It is just awe-inspiring and deeply unsettling. Let's try to synthesize all of this. What we are looking at here is essentially a unified field theory of ancient mysteries.
The true brilliance of these sources is how they take seemingly completely disconnected data points. A mythical mountain in the Mahabharata, a star that optically fell from the sky, a sunken continent in Polynesian folklore, the physical glacial scars of Milford Sound, and a 364-day calendar from a biblical prophet, and they thread a single, unbreakable mathematical and geological line through all of them.
They turn mythology, ancient calendars, and global flood myths into a singular mathematically mapped geological event. It's not magic. It's not primitive ignorance. It is just physics operating on a scale and a timeline that our modern brains struggle to comprehend.
It forces a complete reconsideration of the validity of ancient human memory. For centuries, modern science has looked at these ancient texts and dismissed their geography and timelines as allegory or simple ignorance.
Just stories.
Right. But this theory suggests that the ancients were actually recording extremely precise geographical, astronomical, and temporal data. It's just that they were recording the data of a planet that no longer exists in that shape. They were recording the reality of a pre-contraction Earth.
It makes you look at a modern globe completely differently. I really want you to actually go look at a map or a globe after you finish this deep dive today. When you look at the massive blue expanse of the Pacific Ocean, or the jagged, towering peaks of the Himalayas, or the icy, dead wasteland of Antarctica, I want you to realize that you aren't looking at a static, permanent fixture. You are looking at a snapshot. You are looking at a single, frozen frame in a very long movie of a moving, breathing, and shrinking planet.
It replaces our comforting illusion of permanence with the stark reality of cosmic vulnerability. The 16,000-year process we just mapped out may just be one cycle of a highly dynamic system.
Which brings me right back to where we started today. We talked about how comfortable we are with fixed baselines, like an X-ray showing a clean broken bone. We desperately want the map to just be the map. We want the ground beneath us to be solid. But this deep dive shatters that X-ray machine. It shows us a planetary landscape that is muddy, violent, and constantly renegotiating its place in the solar system.
The ground is only solid until the physics demand that it moves.
And on that note of cosmic vulnerability, I want to leave you with one final provocative thought to mull over. We just spent an hour talking about how the Earth's circumference shrank by 300 kilometers, right? And we explored the physics of how that tightening belt created immense tectonic pressure, crushing plates together to build our modern mountain ranges and plunging entire continents into the abyss. All of that tension, all of that violently compressed rock is currently sitting beneath our feet, locked in place. So here's the question you have to ask yourself. What happens to that built-up, deeply buried geological tension if our orbit were to shift again? Are we truly standing on solid, permanent ground, or are we just enjoying a brief 6,000-year pause between cosmic adjustments?